coupled clusters theory. Or coupled cluster methods. They are essentially the best we can offer nowadays. And in particular, there's one method which is called the golden standard, and that's the CCSD parenthesis T method. So if you go for high accuracy, or you need very accurate results, then typically you go for coupled cluster theory. And it's also in that, therefore also often used sort of to establish reference data or benchmark data for other methods. So if you developed a simpler, cheaper method and you want to know how good it is, then you either, of course, you can always compare to experimental data, but often you also compare then to coupled cluster data. It's in a way different from the other methods we talked about, and you will see that in a few minutes. But it's also very similar to perturbation theory. So let's start. What is different is the way how one writes the wave function up. So the answer for coupled cluster wave function is that we have this exponential operator acting on a Hartree-Fock, on the Hartree-Fock Slater determinant wave function. So it's quite sort of a bit unusual to have an exponential operator. And then the next question is, I mean, what is this T? Well, T is a sum of some other operators. It's the sum of all single excitation operators, all double excitation operators, all triple excitation operators, up to the number of electrons. So basically it's operators which do single and double excited or generate single and double excited determinants when they act on the Hartree-Fock state, and you have them all combined here in this operator T. So for example, if you let T1 act on or Hartree-Fock, then I said you get all single excited determinants. So it's a sum over all single excited I and A, and let's write it with the double sum for a change, multiplied with some coefficient, some weight of those single excited determinants. And in coupled cluster theory, at least how it's written nowadays, those coefficients, those weights of the single excited determinants, they're called amplitudes. And they nowadays typically have the small symbol t, which is used, which in a way sort of fits to the operator being a capital T, and then the coefficients are small t, so they're called, as I said, amplitudes. But they are in a way nothing different from the A's we had on Tuesday and the A's we had in CI and multi-reference CI or MCSCF last week. They are just coefficients in front of the determinants, and therefore sort of determining the weight of this determinant. A T2 then correspondingly is again acting on Hartree-Fock. That gives us then all double excited determinants. And here again we have now a double excitation amplitude or doubles amplitude, and here the double excited slit.